Permutations and combinations. So a permutation is a set of objects. So let's go for it. And take a minute if you need to read that definition. All right. Now, example 1 says we're going to evaluate the given expression without using a calculator. This is going to be basic multiplication. I see that 11 is prime, but 10 can be broken down as 2 times 5. 9 can be broken down as 3 times 3. 8 can be broken down as 2 times 4, and 7 is prime. And that's all divided by the 5 times 4 times 3 times 2 times 1. And since we're multiplying, I can reduce top versus bottom. I see I have a 5 here. I have a 4. I have a 3 and a 2. Now, everything's reduced. Now I'm going to multiply. I got 11 times 3 times 2 times 7 all over 1, but we're not going to write the 1 underneath it because that wouldn't be simplest form. So now I have 11 times 3 times 2. That's going to give me 66 times that 7. And 66 times 7, which is 462. That's my answer. Example 2 says, we're going to evaluate this expression. What is this expression? If you notice this exclamation point, this is factorial. Factorial means I'm going to take that 10, and then I'm going to multiply 1 minus it, 1 minus that one, and just keep going all the way down till I get to 1. However, your calculator would do 10 factorial if it's a scientific calculator. And the answer comes out to be 3,628,800. Now, example 3, we got a little bit more going on here. As you notice, the numerator has a 19 factorial in it over 4 factorial. 19 minus 4 is 5 factorial, or 15 factorial. So since I see I have a 15 factorial, I can break down this 19 to 19 times 18 times 17 times 16 times that 15 factorial. And the 15 factorials reduced. You can do more than one step here. You could have worked on that 4 and the other numbers, but I'm going to do one step at a time. So now I got 19, which is prime, times 18 can be broken down as 2 times 9, which is 2 times 3 times 3. 17 is prime. 16 can be broken down as 4 times 4. And 4 factorial is 4 times 3 times 2 times 1. And now let's reduce. I got a 4 that reduces with the 4. I have a 3 that reduces with 3 and a 2 that reduces with the 2. So now I have 19 times 3 times 17 times 4 all over 1, but we're not going to put it over 1. And when I multiply all those together, I get 3876. Came out to be a nice clean number. Let's do example 4. How many ways can a 2-person subcommittee be selected from a committee of 5 people? So we're looking at this and it's a combination, right? It says a 2-person subcommittee. So what we need to do is write our notation. So we have NCR, where the N is going to be the 5 people. The 2-person subcommittee is going to be my R, because remember, if you read that definition of the R is at R at a time, right? So now my N is 5, so I'm going to write it in my formula method right quick. And let's plug it in. I got 5 factorial over 2 factorial times 5 minus 2 factorial. So I got 5 factorial over 2 factorial times 3 factorial, because 5 minus 2. Well, that means I can write this 5 as 5 times 4 times 3 factorial, all over 2 factorial times that 3 factorial, and let's reduce the 3 factorials. Now I can rewrite the 2 on bottom as 2 times 1, and let's rewrite the 4 on top as 2 times 2, and let's reduce this 2 and this 2. Now I'm left with 5 times 2, which is 10, and that is our answer. So the number of subcommittees here would be 10. On number B here, it says, how many ways can a president and vice president be chosen from a committee of 5 people? Well, now we are talking about a permutation. So I'm gonna write this notation. I got NPR equals, where my N is 5 and my R is 2. Look, we have president and vice president. That's 2. So that's my R. So we can write like this. This formula is N factorial over N minus R factorial. So I have 5 factorial over 5 minus 2 factorial, 5 factorial over 3 factorial. And then I can write 5 as 5 times 4 times 3 factorial over 3 factorial. Reduce the 3 factorials. And now I got 5 times 4, which is 20. And that is my answer. Okay, let's do example 5. A catering service offers 11 appetizers, 16 main courses, and 10 desserts. A banquet committee is to select 8 appetizers, 13 main courses, and 5 desserts. How many ways can this be done? All right, so what I notice going on here is I got a combination of things going on. So what I want to do is list everything that I see that's going on. So my first order, I have appetizers. My second order, I have main courses. My third order, I have desserts. All right. Now, since it's a combination, I know that I'm going to have this formula. Okay, so let's solve for it. Well, we're going to do the first order first. So we have 11 appetizers and 8 appetizers. So in the first one, and if you need to label it, I would come over here and say order 1. Right? So my N is going to be 11 and my R is going to be 8, because it says the catering service offers 11. The banquet committee selects 8. So the 8 is going to represent the R at a time, right? And 11 will represent my total. So now we can just plug that in our formula and solve for this. So now I have 11C8 is equal to 11 factorial over 8 factorial times N, oops, let's go write the formula again, times 11 minus 8 factorial. So I can write this as 11 times 10 times 9 times 8 factorial over 8 factorial times 3 factorial. And let's reduce the 8 factorials. Let's write this out one more. So I got 11 times, well, 5 or 10 becomes 5 times 2, and 9 becomes 3 times 3, all over 3 times 2 times 1. And let's reduce. I got a 3 that reduces. Oh, I left a 3 off here. You don't notice that. There we go. So that's 9. 3 times 3 is 9. Got to watch our numbers, make sure we don't miss something here. So now I got 11 times 5 times 3 So 11 times 5 is 55 times 3 is 165. So that is our probability for order 1 for the appetizers. Let's do order 2. Order 2 is the main courses. And if I come back up here, I can see they offer 16 main courses. So N is my 16. R, it says that we're going to select 13 from the main courses. So that's R. And let's plug it in. So I have C, I got 16C, 13. 16 factorial over 13 factorial times 16 minus 13. So now let's clean this up. 16 times 15 times 14 times 13 factorial, all over 13 factorial. 16 minus 13 is going to be 3 factorial. Our 13's reduced. Now I'm left with 16 times, well, I see I have a 3 that can be written out. So let's reduce what we can. That 15 can be broken down as 3 times 5, and that 14 can be broken down as 2 times 7, all over 3 times 2 times 1. Let's reduce our 3 and our 2. Now I'm left with 16 times 5 times 7, 560. So that's for the main course, that's that probability. Now let's do the last one, for order 3. So let's go back and look at desserts. Desserts says that we have 10 desserts, right? They offer 10 desserts and they're wanting to select 5 of those. So my N is going to be 10 and my R is going to be 5. Plug it in that formula. So now I have 10 times 9 times 8 times 7 times 6 times 5 factorial, all over 5 factorial times 10 minus 5 is 5 factorial. All right, now let's reduce. Our 5 factorial is reduced. I'm going to reduce one more time because I can write this down as 5 times 4 times 3 times 2 times 1 because it's 5 factorial, right? So let's break down the 10. The 10 is 5 times 2. 9 is 3 times 3. And 8 is 4 times 2. And then times 7 times 6. I'm not going to break down no more unless I just need it, and I'll sketch it here in this step. 5's reduced. The 4's reduced. 3 reduces. A 2 reduced. And we're good. Now we're left with 3 times 2 times 7 times 6. So I got 6 times 7 times 6, and that's 252. All right, now that I know all this, the last thing we need to do is we got to take the answer from order 1, 2, and 3 and multiply them together. So I got 165 times 560 times 252, and my answer is 23,284,0 or 800. And that this here is the possible ways to form the banquet. Let's do example 6. An electronics store receives a shipment of 50 cards. 10 of those are defective. And 4 of the calculators, oh, I said cards. My apologies, guys. I got talking about cards earlier. An electronics store received shipment of 50 graphing calculators. 10 of them are defective. 4 of the calculators are selected to be sent to a high school. A says, how many of these selections can be made? So here we go. We're talking about a combination going on here. So I know that I want to use this formula. Oops, don't forget our factorial. All right, so let's talk about it. It says that we have 50 calculators, right? That's been shipped. And then 4 of the calculators is what's been selected. So I know my N is going to be 50 and my R is going to be 4, because remember, R is at time, R at a time. Okay, so now let's just plug it in our formula. I have 50 factorial over 4 factorial times 50 minus 4. I'm going to change this back to this color. So now I'm going to write this down as I got 50 times 49 times 48, but I'm looking here at this parenthesis here. 50 minus 4 is going to be 46, right? So I'm just going to go out to 46 factorial. Right, because I can reduce those two. Right? Now let's go back. Now I see that I got a 4 factorial in the denominator, so it's going to be 4 times 3 times 2 times 1. So I can break 50 down as what? 2 times 25. 49 is made up of 7, so I'm going to leave it alone. 48. 4 goes into 48 12 times. So 4 times 12, well, 12 is 2, how about 3 times 4? Can y'all see what I'm trying to do? I'm trying to reduce my numbers here. And then let's bring down the 47. And let's reduce. The 2s, the 4, the 3. And now what am I left with? I'm left with 25 times 49 times 4 times 47. And my answer is 230,300. And my spacing here is terrible. There we go. So that's how many selections can be made. So that's a combination. B says, how many of these selections will contain no defective cards? So when we come back up here and look again, we got 50 cards. I said cards again, my apologies, guys. Defective calculators. We come back up here and we see we got 50 calculators, and it said 10 of them are defective. So let's scroll down. That means we need to take that 50 and subtract the 10, and that gives me 40. So this is going to be my N. My R says that we're still doing them in 4 selections. And now let's do our combination. We got 40 factorial over 4 factorial times 40 minus 4 factorial. So I got 40 times 39 times 38 times 37 times 36 factorial. And I went that far out because I know 40 minus 4 is going to be 36. And I'm going to reduce those two. And this next one, I'm going to rewrite. I'm going to put 4 times 3 times 2 times 1. So 4, I got, for 40, I got 4 times 10, which 10 is 2 times 5 times 39, 38. Well, 39, 3 will go into it. It'll go into it 13 times. Let's do that. Times 38 times 37. Let's finish this out. So my 4 reduce, my 2, my 3. Oh, we did great. Now we got 5 times 13 times 38 times 37. And that is my answer. So these are the selections that will contain no defective calculators.